Hello. I'm really happy to be here today, just to share with you my learnings. This will be a presentation about some learnings that I have done through a design process just to create a network service. So as the presenter introduced, I'm working for Schibsted. Schibsted Media Group is based in several countries, around 20 countries across the world. Here in Sweden, probably you know about Blocket and also Aftonbladet and other media houses. And the presentation here today will be a journey and also a love presentation. A love story about how network engineers and developers can work together, creating useful services for both worlds. Sometimes this is difficult to achieve. I have been working as a traditional network engineer for almost 10 years, until I decided that I had to move to a more full stack approach. I need to get some skills that I was lacking at that moment. And I decided that the way to go was move to a new company and start from scratch on this way. So all these learnings, all these design decisions, success and failures will be presented here today. Let's start with a short recap about networking, because it's the leitmotif or the aim behind this story, present how a DevOps approach or a more automated way of doing things can be useful for the network industry. I'm not going to go through all the challenges that probably you know, but internet scale technologies and applications are driven a change on how we operate networks. So this focus on scale, focus on velocity, against the traditional reliability concept that the network industry has, is changing the way that we operate the networks. And this traditional network approach sometimes is not good enough. So the question that probably some of you have done, and I did to myself some time ago, was if we were ready for this change. If we look into our networks, we can see that sometimes we have multi-vendor networks, sometimes with legacy devices. Understand which are the difference when you work with legacy devices. For me, a legacy device is a device that the interaction is designed first as a human interaction. If you, as an example, probably you know about an open source project, Napalm. If you go into the code and you go to the different modules, it's completely different how looks a Cisco iOS from a Arista EOS, for instance. Why is the difference? One was designed just for interacting with machines, the second one, and the other is for humans. So the scrapping of the configuration for the same function you get from 3 lines, that is just a get and a JSON parsing, against a scrapping of the lines is completely different. So it makes a big effort to automate these things. Also, going to this way of automating things gives you a lot of opportunities to learn, but sometimes it's also a blocker for you, because there will be a lot of things, not just a few new protocol behavior or functionality. There is a lot of things to learn, and also it's a challenge. The trainings, usually networking, has been really focused on learning things about protocols. If you look, for instance, into the CCI curriculum, you will see that these topics that I'm going to present today are less than 10% of the topics. So we are more focused on the protocols itself, that it's a really important thing, but we are not focused on how to operate and handle it accordingly. Also, some fears that I recommend to think about is the automation amplifies your success, but also your failures. So you could be some kind of afraid of automating things, and a failure impacts in your infrastructure and in your reliability. There are some things to mitigate. I'm going to also to introduce today. And finally, and it's an important thing that at least is my experience, that sometimes network engineers are so far from the developers. And the developers are the ones that are creating business logic and creating value to the company. So if we keep far from them, we are not having the impact that we can get. As an example, I remember working in my previous company that network engineers were in a different building than the developers, not just the different room, different floor, a completely different building. So communication was not the way to go there. And having all this in mind, sometimes it's difficult to start because you have so many things to do that it's complicated to start from something. How we can approach it? I'm not going to go through these specific things because all the presentation is about these, not buzzwords, it's just ways to do things. So starting from working with APIs, business machine-to-machine interaction, to just going through coding skills, iteration, this stuff that makes possible to create things in an agile way is the way that we should start thinking in networking. Without leaving the idea of everything should be reliable, we should start thinking on creating network services that are closer to the applications. So the presentation itself that starts here, and you should expect a demo that, as usual, could fail, but hopefully the video is going to work as expected. I'm going to introduce a network service. And why is it important for a company as Schibsted to have a network service? You can see this as an IT ecosystem nowadays, that we are not only based on on-premise, so a service can be distributed across several platforms. Imagine platform A as an on-premise data center, platform B, another data center, platform C, a public cloud, platform D, another public cloud. So you have several networks distributed, and the service is distributed across all of these. This is what an enterprise company looks like today. And the network is something more similar to this. It's a bit exaggerated, but at the end, what you get is a multiple relations between these services that if you're in a data center, you can implement with a VLAN, with a VXLAN overlay network, whatever you have. If you're running in a public cloud, you can get a specific peering technology, or if you have to interconnect several networks in different platforms, you can run a VPN tunnel, an overlay, or just going through internet. The question here is that there are several technologies. It's nothing impossible, but the most difficult thing to achieve and to interconnect is the different people working with these technologies. And this is what is really difficult to achieve, because there is people operating these services that has some knowledge, and other people have another knowledge, and making these things work together sometimes is difficult. So this model, that is the current one that we have in Schibsted, and we try to improve, has some downsides. The first one, and I think that is the important one, is that by default, what you get is that the services interconnect through internet. Through internet is the default way to connect, but it's not always the most performant way to connect. You can get an internal link that has more bandwidth than going through internet. Also, it's not the most secure and not the cheapest one. If you have to, you usually pay for the traffic that you move to internet, either on your infrastructure, on your premises, to your ISP, or to your platform cloud, you get the same. Also, related to the manual operation or traditional operation, going through a manual process to handle everything is difficult. Difficult to achieve the speed that you are demanded. Developers are used to work with networks, with services that are created on demand, and the network has to follow this. So you cannot say that we will create the connection next week or tomorrow. The connection from different services has to happen at the time that is demanded. Also, you work manual, there are some errors that could happen. Manual provisioning could mean some errors, because following procedures is not something that always happen the same way. And finally, some communications still need some network layer security. Hopefully, most of the applications are running security at layer 5 with SSL or TLS, but there is still legacy applications that still need some kind of network tunneling. So we try to solve all in one, some kind of squad team of network security engineers, basically people with some network knowledge, meet together almost 3 months ago and came up with this cool design. So it's quite easy. It's not rocket science. It's just what it's known in AWS world as transit VPC, that basically you have several platforms, could be public clouds, whatever, or on premises, and you, instead of communicating service to service, you create a virtual router service wherever you want to place these routers, could be in the cloud, on premises, wherever you want, and running some kind of standard technologies like VPN, IPsec, and BGP to routing as a routing protocol. You distribute the routes from one service to the other. All this together, you can just create a central point, define a scale-out architecture, so you can just grow as you want in this place, like a leaf and spine architecture. We also think on how you operate this network, so we just define an automation process using Ansible to create the configurations, go through analysis process, getting the net flow information from these routers, take decisions, and add some kind of logic. So you could see this logic part as a SDN flavor. And we tested this with several routers, vendors. I remember Cisco, BIOS, Arista, and it worked perfect. It was a nice technical exercise. And we came up with this solution. We also tested different VPN architectures, so we tested also the DMVPN. Instead of going to this central point, this is only for routing, for control plane, and we did the data plane here. So we came up with this solution to the upper management, really happy that this is going to solve everything. And this was the result. We failed it. And the failure that we get was really something useful for us, because we learned a lot of things, and things that most of them are not technical, but are things that if you want to operate a service that has to run quickly and evolve as the business or developers want, you have to think as they do. So you have to understand what they really need, not what do you expect that they will need. You have to understand what are their needs, be flexible to accommodate changes, because this is going to happen. It's the traditional project management approach from a cascade to a waterfall versus a continuous improvement cycle. And this iteration should focus on the things that they need in a short term. So with all these lessons learned, we moved to a second phase of the project. It was, instead of creating a network service, we created a network service. So highlighting, stressing the service part. And the difference was not about the technology, it was the approach. So the result of this second iteration phase was, instead of focusing on this part, on the technological part, just focus on the abstraction in this one network box. So our management team was focused first now in running in a public cloud platform. So why not just try to fulfill this requirement first? And if you are running in only one platform, the best way to go, instead of using a central point of routing, is just using internal links. So the project today, what tries to fulfill, and it does, and it's in production for this, is because we solved this problem. You have a platform, we're running a lot of different services, networks, and we interconnect them in an abstract way for the user. So the user only has to interact with this one network, and we fulfill this requirement. Next steps. We can also support another platform. Imagine on-premises, creating VLANs or internal routing, or we can support also another public cloud. We can support several services, just implementing a new dependency with this service. And also not leaving the central point to connect everything. This is still in the roadmap. Hopefully, our product owner will accept this project for the next quarter. But we will just create a full picture of everything. So the requirement that we get from the users is that this service, network service, should be self-serve, self-onboarding. This means that for a developer, they need to use the network without caring about the details. We create something that the developer is completely autonomous, just to create a service and connect to other services. This connection doesn't happen magically. You have to do a lot of things, but it's the network service task to implement them. Also, in all the cases, what we do for them is choose or decide from themselves which is the best connection that they can get. So they are in one platform, we want to connect to another platform, they don't care about where this is the other platform, and we decide which is the best connection that they can get, and we implement for them. So everything is self-serve, autonomous, and we also keep monitoring, understanding that the connection is healthy, communicate with them, notify, and provide useful network information. Sometimes we forget that the network has information itself. and we are not communicating to the developers. For instance, probably you are managing net flows or in your network. But are you passing this information to the developers to understand which are the network dependencies on their services? Sometimes not. This is the architecture, quite simple. Basically, are two main services. One is the API is a RESTful API. Everything is implemented in dynamic infrastructure, so you don't have to fear about dynamic infrastructure. We can run this in the cloud, on premises, wherever, but we run this in a dynamic infrastructure, having the coupled infrastructure, that we just implement the API that is the one that the user interconnects to the load balancer. And the magic happens here, happens in the worker. So the worker is the one that has the dependencies with the libraries, with the different providers, just to implement how we connect, how we run a network service there. So now you can see that the dotted lines means roadmap. Currently, we only support AWS. This is using infrastructure as a service. So we run everything as code. Everything is versioning. Is running in a dynamic infrastructure, so the number of workers scales up and out. Also, it's important to note that we are running in an authenticated service in a single sign-on, so the user has to run this API being authenticated, so we have a secure service. Not everyone can access the service from the company and change things. And also it's interesting to notice, because it was something that I learned when I started this process to become a DevOps, is that the dynamic infrastructure, the monitoring services, either the metrics and events, doesn't have to be pulled from the device. The service itself, the application, should notify to you in a central point that something has started. Because the worker that you have today could be not the same that you have tomorrow. There could be a new deployment process, an escalation that creates a new service that has to be registered, and the old one is going to be disappear. If you have to troubleshoot this, you have to know everything that happened all the time. So this is the architecture, quite simple because the project is starting and it's in production from some few time ago. Here we have the entities, just to you realize that this is a project that really works. What we map it is this concept of a service that is a group of different resources that are the networks that runs in different providers, and finally you create the connection. This is mapped here in the database objects that you can see as a service. Is nothing else than a list of owners, users that can handle this service. Service has a list of providers. A provider, in this case, in a case of AWS, is defined by the account and the region. And finally, the resource is something that we get automatically. So we scan the resources from you, and we get the subnet, so a list of different subnets, the IDs, layer for filtering. We implement also ACLs in the network. And finally, what you get for the user is you try to establish a connection. And this connection is nothing else than a resource to another resource. And as a user, you don't care about if this is just a link or it's a new route that is published running a routing protocol. So finally, this is the connection that gets the details of the connection, and you can track and monitor this. Everything, as I explained it, is a service. So a service, I don't know how much are you used to create services, but this is just an example of a continuous integration deployment process that we run inside the team just to create this. So it works with a version control system that every developer works in the different features that finally goes through a unit testing integration test that you centralize in a notification process, goes to the code review. So the code is not your code is the team code. And this code, when it's reviewed by the people, and this is a really good point, because reviewing the code, you learn more than you think. So reviewing what the other does, and also getting the feedback from the others is a good way to learn new things. Not just go to more than 100 comments, but it's a good way to learn. And finally, you still go to a final unit test process and the deployment process. Because at the end, you get a service that is an artifact that goes to a repository of artifacts, and you start the deployment process. So we do everything here in an automated way. You create a new feature, it's reviewed, and it's deployed. So it happens completely transparent for the user, and the user still has access to the service in production all the time. Look here in this acceptance test, because it's what we are going to look in the next slide. The next slide, that is the demo part, is nothing else than the specific end-to-end test that we are using to deal with a new release of this code. When we create a new code, we just deploy this, and we get, at the end of all this process, end-to-end acceptance test. We check that this new release of the service is not broken anything, and if everything is working as expected, we deploy this in production. This demo, it's just 3 minutes. It's running in AWS, and it's a manual process of running the end-to-end test to create, between 2 different accounts, a link in AWS. How it works, basically, this is AWS console. I don't know how familiar you are with it, but you can see that first of all, we deploy with code. We deploy 2 different instances. You can see here that we are deploying stacks. And stacks in this case means that we deploy 2 different networks in 2 accounts with 2 instances, virtual machines, just to check that they can see each other through an internal link. This takes some time, because you have to create all the resources on the public cloud. But eventually, in a few seconds, we will see that now we have here an instance. In this account, we have this instance. In the other account, we will have another instance. Here, we are checking that in the routing part of the instance, in the root table, first we have to go to the subnet that this instance is attached to. In the root table, we will see that you have the local route, so your local network, and the internal route. This is what you get by default, before creating the network connection that we are going to create with this service. So once the stack is created, we try in each instance to ping each other with internal IPs. So we get the public IP, we connect from the SSH terminal, and we create a ping, just to know when the other, you can see here, but at the bottom of this image, what you get is a ping from one instance to the other, just to wait until all the service runs. So what you are doing here is in the global network service, you create these assets, basically 2 different services, 2 different providers. Automatically, the service connects to your provider. We have the rights to do that. And we discover 2 different resources, 2 different VPCs. And now starts the process. What we are doing here is that we create now a connection. And the connection takes some time to be established. You have to think that what we are doing here is not only creating the connection. This is something that you can do in the console. We are doing it through an API, interacting with AWS. But the cool thing for the developer is that we are not only taking care of the link. We are also taking care of the root table and also taking care of the security groups. So finally, when the connection is created, you have seen here the ping. We are going to see again. But what you get is a new connection. And the difference for the user is in the root table. Eventually here, when we refresh, you see that we have added a root table with the route and the link. So you can see here that we can ping each other with an internal link, and the test verifies that this happens as expected. This is a way for the developer to get a running connection without caring about any detail. And also, the same way that you create a new connection, you can delete a connection. So we just delete everything and keep the scenario completely clean. For the user, this is something that they have a service that takes care of everything in the network, so they can just develop business logic, add value to the business, and we can focus on these things. Why our developers use it? I don't say like it, but just they use it. And they use it because we take care of the underlying details. So for them, it doesn't make sense to learn about real networking or root tables. They only have something that works. And this works means that we also take care of get the best connection. The best connection is the cheapest one, the most performant one, and also sometimes you have restrictions about how many links you can get. If we get a limitation on this, we create a new kind of connection. We give them one API. They love APIs. They need to have an API to interact. And we create that only one API to all the different platform services. We keep them notified about connection health. So periodically, we are running a watchdog that checks that the connection is still established, the root table is as we expect to be, and if there are any change, we report a notification to them. Finally, what they get is a out-of-the-box solution to run over multiple platforms. Everything is simple for them. And they get this extra value that is information about the network, what's happening behind. So it's just not the code with the library dependencies. They really understand that the service is talking with other services. So to close, wrap up this session, takeaways that I take through this process that was around 4 months to create a minimum viable product. It was created by mainly 2 engineers. Lately, more people has come to the team, more software engineer oriented, and they are refactoring everything, but the idea is just the same, create something that handles the network for you. So I will recommend to everyone here in the room, as a traditional network engineer that want to move to a more automated way of doing things, a DevOps approach, don't be afraid of doing this step. I did this 3 years ago. It took some time, some effort, but it was really worthy for me. Also, you should learn some kind of coding. I'm not saying that you have to become a software engineer, but something coding will you make able to join pieces, because it doesn't matter if you buy an out-of-the-box solution from a big vendor. At the end, you have to do some kind of glue between the different pieces, and you have to learn about coding. And adopting this approach, I can say that will speed up the business and also your career, because you get more skills. And don't forget this. Networking is still a key IT skill, but we should be able to bring it close to the business. And that's all for my side. Thanks for your attention. And I leave here you just a link that I have done just to list some of the learning materials, blogs about networking, about Linux networking, DevOps practices that I have been going through during these last 2 years. So thank you very much.
Thank you, Christian.